Deep in the ocean, there is a creature that hunts with a gun made of nothing. The pistol shrimp snaps its claw so fast, the water rips apart. A bubble forms. But when that bubble collapses for a split second, it generates temperatures hotter than the surface of the sun. This isn't magic. This is sonoluminescence. The art of turning sound into light. Scientists have taken this chaos and trapped it in a jar. A levitating star suspended in liquid. It glows for days. It emits UV radiation. And inside that microscopic point, physics is screaming. We are talking about 20,000 Kelvin. Some say millions. Enough to potentially fuse atoms together. If we can control this, we unlock infinite, clean energy. The Holy Grail. A sun in every home. But if we get it wrong, we're just playing with bubbles. And historically, bubbles burst. Careers have been destroyed trying to prove what happens inside that light. It is the most controversial field in physics. Is it fusion? Or is it a mistake? To understand the star in the jar, we have to go back. Back to 1934. When the British Navy wasn't looking for light, they were looking for invisible enemies. Sonar was the new eye underwater. But operators kept reporting a ghost. A noise that shouldn't be there. Ship propellers were disintegrating. Not from rust. Not from enemy fire. Something was eating the steel. They called it cavitation. When a propeller spins too fast, it tears a hole in the water. A vacuum. Nature abhors a vacuum. The water rushes back in to fill the hole. It slams shut with the force of a bullet. H. Frenzel and H. Schultes were testing this in Cologne. They put an ultrasound transducer in a tank. They expected bubbles. They didn't expect the darkroom to light up. The water was glowing. They had no idea what it was. They noted it, shrugged, and moved on. The war had bigger priorities. For 50 years, this phenomenon was a mess. Millions of bubbles exploding at once. Unpredictable. Unmeasurable. It was called multi-bubble sonoluminescence. A fireworks display where you couldn't study the physics. To understand the star, we needed to isolate it. We needed to catch just one ghost. Most physicists ignored it. Fluid dynamics is messy. Light emission is quantum, they don't mix well. Enter Felipe Gayton, 1989. A graduate student who was just trying to calibrate an unrelated experiment. He wasn't trying to make light. He was trying to trap a single bubble in a standing sound wave. By tuning the frequency perfectly, gravity is cancelled. The bubble floats. Trapped in an acoustic cage. Gayton turned down the lights. He cranked up the acoustic pressure. He wanted to see how the bubble collapsed. He looked into the flask, and there it was. A steady, unblinking, electric blue eye staring back at him. Single bubble sonoluminescence. SBSL. The chaos was gone. The star was stable. This wasn't random, it was clockwork. The bubble expanded and collapsed 30,000 times a second. The flash of light was so synchronized, the jitter was less than 50 picoseconds. That's atomic clock precision. Seth Putterman at UCLA took notice. He realized this wasn't just fluid dynamics. This was energy concentration. Think about it. Sound energy from the whole flask is focusing down to a point smaller than a blood cell. The energy density increases by a factor of 1 trillion. That's like shouting at a coffee cup and boiling the ocean. Putterman asked the big question, if we are concentrating energy this much, how hot is it really? To measure temperature of a star, you look at its color, the spectrum. Blue means hot, UV means hotter. But the light from the bubble was weird. It didn't have spectral lines. It was a perfect continuum, like a black body. And it stopped at the limit of water transparency. The water itself was absorbing the highest energy light. So they calculated backwards. Conservative estimates, 10,000 degrees. The surface of the sun is only 5,000 dal. At that temperature, atoms lose their electrons. The gas inside the bubble turns into plasma. The fourth state of matter. Why? Because the bubble wall is moving at Mach 4, 4 times the speed of sound. In liquid, the gas inside has nowhere to go. It gets crushed, violently. It's a kinetic hammer blow to the atoms. This is Bremsstrahlung radiation, breaking radiation. Electrons slamming into ions and releasing photons. But here is where it gets crazy. The model suggested 10,000 degrees might be the floor, not the ceiling. If the collapse is symmetrical enough, If the shockwave focuses perfectly, the core could be millions of degrees. And at millions of degrees, you don't just get light, you get nuclear fusion. Fusion, the power of the sun, clean, limitless, usually requires a reactor the size of a stadium. Could we really do it on a tabletop with 50 worth of glassware? It sounded insane. But science doesn't care if it sounds insane. It only cares if it's reproducible. And that was the problem. As they pushed the bubbles harder to get hotter temperatures, the bubbles fought back. They became unstable. Pushed too hard, the bubble deforms. It turns into a chaotic wobbling mess, shape lost, focus lost. The shockwave misses the center, the star dies. We hit a ceiling 20,000 degrees. Hot, but not hot enough for fusion. The dream stalled. Sonoluminescence became a parlor trick, not an energy revolution. Al is lost. We needed millions of degrees. We were orders of magnitude off. But failure is data. Physicists gave up. Chemists, they looked at the air. Nitrogen is soft. Oxygen cushions the blow. We needed a harder gas. They tried noble gases. Argon, xenon, atoms that refused to react. 1% argon added. The light didn't flicker. It exploded 100x brighter, visible in a lit room. The star in a jar was back, and angry. Argon is an anvil. It takes the full force. Compression efficiency skyrocketed. We could change the gas. Now, could we change the liquid? Water cools too fast. We needed a liquid that could hold the fire. Enter Ruzi Talyarkin, Oak Ridge National Lab. He wanted power, not just light. He brought the big guns. No water. He used acetone, flammable solvent, specifically deuterated acetone. He replaced hydrogen with deuterium. Heavy hydrogen. This is the fuel of stars. If you smash deuterium hard enough, it fuses. And it releases a specific signature, a neutron. Neutrons are the gold standard. Light is pretty, but neutrons are proof of a nuclear event. Talyarkin used a neutron gun to seed the bubbles. He hit the liquid with a shockwave from all sides. The bubbles were monsters, millimeters wide. When they collapsed, the violence was unprecedented. Imagine the Eiffel Tower crushed into a marble in a nanosecond. That is the density we are talking about. 2002, the experiment runs. Talyarkin checks the sensors. He hears the sound every physicist dreams of. Click, click, the detector screamed. High-energy neutrons were flying out of the flask. He also found tritium, the radioactive ash left over from a fusion fire. The smoking gun. This implied the core temperature wasn't 20,000 degrees. It was 10 million degrees. Tabletop fusion. He submitted to Science. The top journal. They were skeptical. They demanded a check. Two colleagues at Oak Ridge, Shapiro and Saltmarsh, tried to replicate it down the hall. Same equipment. Same liquid. They flipped the switch. They saw the light. But no neutrons. The graph was flat. Just background noise. The result was negative. They claimed Talyarkin's neutrons were from the gun, not the bubble. A counting error. Science magazine did the unthinkable. They published the discovery and the rebuttal on the same day. The media went wild. Bubble fusion was catchy. Talyarkin became a star. He moved to Purdue University. They gave him a lab, funding, and a mandate to prove it. He published again. More neutrons. More tritium. But the independent checks were suspicious. The people verifying the work were on his payroll. The walls were starting to crack. Then came the whistleblower. A student from inside the lab broke the silence. He claimed the books were cooked, that the radioactive source was moved to fake the signal. It wasn't physics, it was magic. And in science, magic is a crime. 2008. Guilty of research misconduct. Talyarkin was disgraced. Bubble fusion was dead. The scientific community turned its back. Sonoluminescence became a dirty word. But here is the twist. The fraud was about the neutrons, not the light. The plasma is real. Modern confirmations show it really is hot enough to shred matter. It might not be fusion, but it is a microscopic incinerator, a thermal weapon. We threw the baby out with the bathwater. The machine works, just not how he said. Now, we use it to kill cancer, to destroy pollution. The failed star is saving lives. Nature doesn't care about our politics. The physics remains true. And looking back, the pistol shrimp had the right idea all along. Speed is key. We are now using lasers and projectiles to mimic the bubble. Inertial confinement. The bubble taught us that if you squeeze matter hard enough, you get a star. Taleyarkhan failed. But the science? The science is just getting started. Taleyarkhan was out. But the physics remained. And in the shadows, other scientists kept asking, was he totally wrong? We threw the baby out with the bathwater. The fusion claim was tainted, so nobody wanted to touch the light itself. But in 2010, legitimate studies confirmed something crucial. The core is plasma. It is thousands of degrees. You don't need fusion for this to be world-changing. You just need extreme chemistry. Think about it. We have a localized hotspot that can rip molecules apart. It's a microscopic incinerator. Researchers are now using sonoluminescence to destroy forever chemicals, PFAS, pollutants that nothing else can kill. In medicine, we are looking at sonodynamic therapy, activating cancer-killing drugs deep inside the body using only sound. And of course, the military is watching. Focused sound that creates light is also a way to create focused shockwaves. The controversy faded, but the wonder returned, and we realized nature had beaten us to it millions of years ago. The pistol shrimp doesn't use lasers or nuclear reactors. It uses speed. It mastered the bubble collapse. Evolution designed a fusion-adjacent weapon. If a shrimp can do it, why can't we perfect it? Today, the research is quieter, more rigorous. No more press conferences, just data. We are finding that by tweaking the gas pressure, we can sustain the light. Not just flashes, but a steady beam. Some labs are using crystals to focus the sound even tighter, beyond the limits of glass flasks. We are inching closer to the temperature threshold, not by cheating, but by understanding the turbulence. The story of sonoluminescence isn't about free energy. It's about the limits of our understanding. Some theorists believe the light isn't just heat. They think it's quantum vacuum radiation, the Hawking radiation of a black hole, the Casimir effect, pulling energy from empty space. If that's true, this bubble is a window into the fabric of reality. We look into the bubble and we see our own reflection, our desire for power, our rush for glory, and our capacity to fail. Science is self-correcting. The fraud was caught. The real physics survived. That is the system working. Now, a new generation of startups is picking up the torch. First light fusion in the UK, projectile fusion. They aren't using sound. They are firing projectiles at falling fuel pellets. But the principle, it's the same. Collapse, inertial confinement, crushing matter faster than it can escape. The bubble taught us how to do that. And they are getting results. Not falsified ones. Real neutrons. Real energy gain. It's happening. It took 80 years. From a confused Nazi scientist in 1934 to a billion-dollar startup in 2024. We wanted the star in a jar to be easy. It wasn't. But the hard road led us to something better. It led us to understand that sound is not just noise. It is a physical hammer. A tool to reshape matter. The universe hides its best secrets in the chaotic edge. In the turbulence. In the collapse. Maybe we will never power the world with a single flask. But we might power it with the lessons the flask taught us. A bubble of air, a sound wave, and a flash of light. It is simple. And it is impossible. But wait, there is one final frontier. Space. On Earth, gravity distorts the bubble. In space, the bubble is perfect. Perfectly round. NASA is investigating sonoluminescence in microgravity. Without buoyancy, the bubble can stay in the center forever. A perfect sphere means a perfect collapse. No potato shapes. Maximum concentration. Maximum heat. Could this be the engine of the future? A fusion drive powered by sound. It's theoretically possible. Or computing, using light pulses from bubbles to transmit data faster than fiber optics. Acoustic computing. In 10 years, we might not have bubble fusion, but we might have bubble surgery, or bubble sanitation. The most exciting part isn't what we know. It's what we still don't understand about that blue light. Is it quantum? Is it nuclear? Or is it something else entirely? A new branch of physics waiting to be written. It takes a special kind of mind to look at a bubble and see a star. Maybe that mind is yours. If you enjoy videos that go deeper than headlines, and actually explain how the world works, you're in the right place. Subscribe to the channel so you don't miss the next breakdown. Hit like if this video helped you see something differently. And if you have a question or a topic you want explored next, drop it in the comments. Your curiosity drives this channel,